From UFOs to psychic powers and government conspiracies, history is riddled with unexplained events. You can turn back now or learn the stuff they don't want you to know. A production of iHeartRadio.
Hello, welcome back to the show. My name is Matt. Our colleague Noel is on a big adventure, but will be returning shortly.
They called me Ben. We're joined, as always, with our super producer, Dylan, the Tennessee pal Fagan. Most importantly, you are here. That makes this the stuff they don't want you to know. Let's get physical. Physical. Remember that song?
I do, unfortunately. I remember this song, yes.
It's not exactly, Pulitzer or Nobel Prize material, but Matt, this evening, you and Dylan and I are getting into physical ideas in a literal and, oddly enough, abstract sense. This is going to be a kind of loose exploration and conversation with us and with our fellow listeners, because we're going to the very first science, a subject that has thoroughly baffled humanity since antiquity, the study of what we call physics. Did you take many physics classes in your school days?
It took me a couple physics. Yeah, did that mostly in the college sphere, but, a little bit in high school. Physics are very interesting because it's really one of the most basic sciences, yet it seems to, or it feels as though, at least from my perspective, to be one of the most difficult to fully grasp.
Yeah, agreed, right? We're coming to you as a collection of nerds from the alma mater How Stuff Works.
And Georgia State University.
And Georgia State and Georgia Tech and all the hits.
Georgia Tech's a little different. That's probably a little better in a physics course. No offense, Georgia State.
Oh, man. I don't know. The professors at Georgia Tech, you know this, and we know some of those professors, they pride themselves on being pretty brutal, especially those poor first-year students in STEM. They are, I didn't go there for STEM. I went there for international affairs, but they pride themselves on like failing a certain number of students per course.
Oh, yeah. I have several friends who were so excited to be at Georgia Tech. They're like, oh, man, we made it. Got those good grades. Got into Georgia Tech. Holy crap, first year.
Yeah, it's sad. Like the second year students in engineering, mathematics, and physics, they look like they've been in a war. They've got that 7-league stare, the haunted, sunken eyes. And anyway, shout out to Rocky Mountain Pizza.
Yeah, well, strap in, everybody, because you've got over in this corner a fine arts degree in video and film production / journalism and an international affairs student. And, even Tennessee pal says physics classes were the bulk of his fine arts degree.
Yes, good to know. We are, as always, unlike the nature of reality, we seek to be transparent and understandable, like the snark there. So we're going to go in several directions in tonight's exploration at varying velocities. We, by no means, as you can tell, folks, are physics professors. But even, Matt, even from a lay perspective, it's astonishing to note just how much strange stuff is coming from this ancient discipline recently. So tonight's question that we were talking about at length off air over the past few months, could civilization be close to breaking physics? As in, will new discoveries soon fundamentally rock our understanding of this crucial science?
Yeah. And what happens if the math doesn't work out for some reason? We base everything in whether or not the math works, right? With the equation. Okay, does it function in that way? What if that part doesn't matter?
Right. Why is there so much emphasis put on the observable part of observable universe, and what happens when we start observing things we simply could not observe previously? Ooh. here are the facts. All right. Well, Matt, as we always do, we decided that it is important to understand what physics is for all of our fellow non-physics professors in the crowd. We got to answer that question before we get into the nerdy controversies and conspiracies surrounding physics today. I mean, look, the basic story of physics is amazing, dude. How it is a discipline today, a field of study, what it is, how it came to be. I think we got really close right there at the top, but let's just spell it out for everybody. What is physics?
Okay, so you are a form of consciousness hearing this. You're inside what we call a body. Probably, hopefully. And that body interacts with stuff that's outside of the body. And everything that you can interact with and everything your body is, and all the way up to the largest things, all the way down to the tiniest components. Physics is the study of how all of that stuff works together to give you this experience that we call consciousness.
Mm-hmm.
Is that
or
kind
reality.
of a way? Is that a way to put it?
I like that. I think you've got some poetry to that one, Matt, because it's a we call it the first science, and that is also poetic, but it is not hyperbole. It's just what you described there: the structure of matter, the interactions between the fundamental components of, again, the observable universe. So as you were saying, everything from the mighty macrocosmic movements of galaxies in the heavens to the activity at the tiny, tiny, tiny sub-microscopic levels, all the way down to quarks. The term itself, for etymology fans in the crowd, comes from Latin physica, which just means study of nature, simple enough. That comes from a Greek word, physike, natural science, and that comes from another Greek word, physis, meaning origin, nature, property. In this sense, physics is the grand attempt to learn how everything called reality works and what can be observed from it. So no biggie, It's like, what are you doing this weekend? Just figure out physics.
It really is the great work. I mean, there are different versions of the great work, but the great work is just figuring out what in the hell's going on. What is this stuff that we're moving through? And within physics, you get studies of time, because ultimately that is, how does this stuff, all of these components, how do they work together from this moment to this moment to that moment to, 200 million years ago to a billion years from now.
Yeah, exactly. And what happens when linear time, one of our foundational assumptions or axioms, no longer seems to hold true? This gets nuts so quickly. All right, the goal of physics has always been to create a streamlined, consistent collection of just a few principles that apply to everything, explain all the apparent contradictions between different interactions and processes, and also to explain how those things work together to create this culmination of mechanics, right? That we call the universe and indeed consciousness. And to get a little ridiculous historian about this, yeah, it's the oldest, most fundamental branch of modern science. And its origin story, as a result of being so important and so baffling, the origin story is inspiring and super frustrating, mainly because civilization learns one thing and says, okay, we got it, right? Thermodynamics, super solid, good, that great job, team, that's lunch. But the more new stuff we seem to learn, the more challenges arise to things that we thought were conclusively solved. I mean, this reminds me of our series on, weirdly enough, astronomy, or astrology, I should say, and governmental figures, right? Because modern physics comes about because people started practicing astrology.
Oh, yeah. Well, and it pops up independently. I'm not kidding when, or I'm not trying to be weird when I say you are a point of consciousness and everything that we observe from that point of consciousness is reality. I just mean that's what every human being has experienced that is born and then can see and can hear and is just looking out and looking around, and you see the stuff, right? And you can figure out that that's a tree because somebody hopefully tells you it's a tree, or you named it a tree, or in whatever language you speak, right? But every one of those people also was able to look up at those times, wherever they were, whenever they were, and see the heavens. And that moment of being able to observe something that is so far away, or just all you can do is see it. You can't ever touch it. You can't ever smell it or use your other senses on it. You can just see it and you know it's there. I think all of humanity across the world, when they look up, they go, what is that? Why is that? And what does that mean?
Right. What does it all mean? Yeah, to quote Philharmonic, what's it all mean? I used to say, and you remember this, I used to often in more nihilistic days just note that everything, including humans, were simply objects in space. But I think it's more appropriate to say, from the standpoint of physics, it's more appropriate to say everything and every consciousness is a series of processes existing in space, right? You are kind of a song that you sing to yourself, right? And that gets us to the other things. Like we said, this is going to be loose, but that gets us to the idea of duplicating consciousness through electronic means. Could you simply emulate a pattern? If so, does that mean you could Xerox a soul, or what passes for a soul? These are deep questions, but these are also the kind of deep questions, surprisingly, that physicists will deal with because their roots arrive from astrology, natural philosophy. In those early evenings that you just described, Matt, science and spirituality were inseparable. And these were smart people. Early scholars could, say, predict eclipses, the passage of the seasons. They would know about changes in the weather, up there with a lot of modern meteorologists. But the difference was they were much more likely to assign divine or spiritual agency to those observations. So now it's not necessarily a lunar eclipse or a solar eclipse because of the passage of Earth in a heliocentric system. Instead, God is angry, right? And God told you God was going to be angry later.
Certainly. Absolutely.
All right, this whole spirituality science thing, it begins to change back in the 6th century BCE, as we call it now. This is where scientific thought emerges in ancient Greece, and this is where we introduce our first hero of the story. You can hear him coming, a guy named Thales of Miletus, who is often cited as the first physicist ever.
Oh, yeah. This dude's awesome. This dude is super awesome. He thought that water was the basis of all matter. But I would argue he wasn't that far off. It just would be the basis of all known life. Water is certainly, the basis of all known life, but not matter. There's other stuff going on.
Right, yeah. And this guy, in his defense, he didn't have a microscope. Right. He didn't have a particle accelerator or any of the cool new toys we have in modern evenings, but he did spend a lot of time in deep thought. And you could argue then with that ability, he had a distinct advantage over a lot of modern society today, which does not really prize deep thought. So he gets that part wrong, but I agree with you, man. He was on to something. Another thing he and his contemporaries did, this is their real sleeper hit. They said, we're going to attempt to explain the world around us without resorting to mythology or spirituality. Sure, Zeus is the god who commands lightning, right? But what if we could explain it without Zeus? Is Zeus going to get mad, or can we just figure out what's going on?
Well, yeah, even if it is still Zeus making the lightning, how does Zeus's lightning work? What happens here physically in our plane when Zeus decides to throw some lightning? That's pretty cool.
Right, because there has to be some process, right? There has to be some some sort of method to the madness. In their pursuit to do this, they create a philosophical basis for rational inquiry. And the roots of this are still very much the formative basis of modern science today. They called this natural philosophy, meaning let's think about natural processes without leaning on gods and spirits as a crutch. Now, this sounds very obvious, of course, in a secular modern world, but this was like a banger. This was a banger, dangerous idea when it happened. And then you got folks like Pythagoras, a favorite of both of ours. Pythagoras, super into math. And he said, look, everything you see or encounter can be explained, discovered, understood via the beautiful art and science of mathematics. And then you got folks like Democritus who speculate. He walked up. This is brilliant. This is so weird. This guy, thousands of years ago, walked up one day and said, you know what? I've been working with one of my teachers, and we think all matter is not necessarily made of water, no shade on Thales, but we think all matter is composed of tiny, tiny little things. They're called atoms. They're the smallest thing. They're so small you can't see them. You can't divide them. He was wrong about that. History would show. And people said, oh, tight, dude. Do you have any evidence for this? And he went, I got a hunch. I got a feeling. I got a spidey sense. And people said, okay, yeah, that's interesting. We're going to put your ideas right here on the fridge.
Yeah, there was no fridge.
There was no fridge either. Yeah. 2,000 years later, though, atomic theory proves the broad strokes of his philosophy to be correct. And there are plenty of missteps along the way. A lot of the scientific shibboleths have informed Western thought for centuries and centuries. Like we've all heard of this, the idea that the universe can be described as 4 elements: earth, air, fire, water. Later, someone says quintessence, right, is a 5th state of matter, and that is the great bowl or sphere of the heavens.
Well, that's kind of cool. That's a cool thought. It's a really cool thought. The atoms thing, we're already breaking things down as far as they can go. Even though there's no microscopes, as you said, humanity is attempting to go as deep as we can, right? And we are also, in this time, building pieces of glass that can see further and further into space, therefore larger and larger things at the same time. So it is just really, it's cool to think that humanity is exploring the concepts of above and below simultaneously, and those 2 different disciplines or those 2 different pursuits are increasing on this line that we can kind of follow. We can look at this graph as like man's ability to break down things and get deeper is not exactly simultaneously, but increasing in the same way that it is to see larger, deeper, older things.
Absolutely. Expanding concurrently toward both ends of an observable spectrum, and then getting to the edge of that spectrum and asking what else is out there in that horizon, or indeed that chasm. So,
and then the next piece of technology comes along, and you do get to go a little bit further, right?
Just a little bit.
Just a little.
And then you look back and you realize, oh, crap.
Yep.
The other stuff was wrong. So, we got to shout out so many people. We're not going to get to them all, but let's shout out Aristotle. He's kind of the LeBron or the Michael Jordan of physics during his time. So this guy sits down and he looks at everybody else's ideas, or all the ones that he can access, right? All the stuff he's read, and he's very well read for his time. And he says, let me bring all these things together. Let's make one sort of posse mixtape theory about the way the universe and reality works. He also is imperfect. He popularizes the cartoonishly incorrect idea of a geocentric heavenly system, meaning Earth is in the middle, but hey, Even Michael Jordan didn't make every layup. The thing is, people respected Aristotle so much that he got just enough right for both his correct ideas and his incorrect ideas to dominate European science and Islamic science for thousands of years after his death. At that point, the modern world does owe a lot of debt to the Islamic Golden Age, wherein Muslim scholars preserved and elaborated on Greek thought as Europe largely languished, and a lot of people have a problem with describing that era as the Dark Ages. But Europe was, fallen. I was going to say falling off the horse. I don't know if that's an idiom in English. Europe was falling behind, and some of this knowledge could have been lost to antiquity had it not been for the brilliant Muslim scholars of the Islamic Golden Age. And now we see physics, therefore, becomes this intergenerational, global, historic epic. It spans all races, all creeds, all cultures, all religions. There are too many luminaries for Matt and I to shout out here. I mean, just think of the scientific revolution alone, right? But we could argue this is a good thing because it turns out it takes a lot of people working together over time to understand what we call the universe, or even to define the universe.
And with all of that, years and years pass, at least as we experience them, and human beings are born and die and born and die, born and die. And finally we arrive at the modern day, where there are scientists across the globe attempting to search for things we have yet to fully grasp. And even the things that we think we grasp, there are scientists attempting to break those systems and those thoughts so that we can move forward in maybe a different way. Because just like back then, as we described in Europe, maybe our thinking is stuck in some ways, or, went back the wrong way and we just haven't realized it yet. And that is super freaking cool.
Yeah. I think physics is best understood as a conversation rather than a set of tablets and directives.
Almost a philosophy.
Yes, very much so. Yeah, especially when you get to the edges, which we'll talk about. As any hapless undergrad student can assure you, and shout out, by the way, to all the up and coming college students who just got their acceptance letters. Congratulations. And good luck. But if you are a hapless undergrad student, then you know well that physics is deceptively deep water. It starts out simple enough, right? Thermodynamics, I get it. The creation, destruction, etc., transformation, matter, I get it. But then you turn to the next page and this quickly becomes so complicated. And like you were saying, if you go far enough into the outskirts of accepted thought, if you go out there to the bleeding edge, the ink of science that is yet to be determined, you'll hit a conceptual landscape that feels a lot less like STEM and a lot more like philosophy or metaphysics. And they'll readily admit this. The world's greatest physicists, especially with the crazy questions, they're essentially guessing. They're leveraging thousands of years of knowledge beforehand, their own deep acumen, theoretical analysis and experiments. But these guys literally make bets with each other about a possibility or a theory. And it's almost never a huge amount of money. It's like, I bet you $1 that this is the thing about black holes. And the other guy says, all right, tally ho,
And then nobody gets paid ever because when will we find out about black holes? One day, maybe.
Oh, gosh, hopefully in time. So this is inspiring, frustrating stuff. And here we are, 2025. That's just a brief look at the origin of physics. There seems to be something new ever on the horizon. And I think a big part of that is due to technological breakthroughs that have made it possible to prove some of these guesses, models, or theories. The question is, could these end up breaking the concept of traditional physics as we know it?
Yes. Yes. And we'll tell you about those in just a moment.
Here's where it gets crazy. All right, so as we know,
actually,
yes. So bizarre. How bizarre. There are different branches of study in physics. We all know that. Classical physics is concerned with the stuff you see every day. I pick up a wallet, I drop the wallet, gravity, right? And you can always encounter gravity on the planet in your day-to-day activities. It's kind of a Goldilocks zone of phenomena, right? So we're dealing with speeds that are always much lower than the speed of light. We're dealing with sizes, to your point, Matt, that are much larger than atoms, but they're still, like, in astronomical terms, they're teensy, teensy tiny. And really, human civilization is pretty good at understanding stuff on this level. The problem is, as you alluded to, once we get to the very extreme ends of the spectrum, the very, very tiny stuff, the very, very big stuff, those rules are less sacrosanct. They get fuzzy. They start to erode.
Yeah, that's where you get, miles and miles of a tube that's filled with magnets, and then we throw single atoms around and accelerate them until they get crazy fast, almost the speed of light, and then smash them together and see what happens after. Mm-hmm. And then you find new particles that you didn't know existed, or subatomic particles and stuff that goes even deeper than that. That's when you get the black hole stuff, and you try and speculate on what does the black hole actually look like and how does it actually function, this thing that we kind of observe out there.
Right, yeah. This is the rise of what we call modern physics. And you have to wonder what history will call modern physics in the future. It's just a tricky term. It's like that irritating term in literature, postmodern. Mm-hmm. The heck is postmodern? Anyway, so
it's just quantum.
Right, there we go. I like that. I'm more into quantum literature. I've written all the novels at once. Shout out Borges. But okay, modern physics, now we're talking high velocities, very tiny, tiny distances, very large energies. This is where you find relativity, very high energy, special relativity, speeds kind of like the speed of light, and of course, the infamous quantum mechanics. That's the thing, man. Despite the fact that many undergrad or high school students may feel physics is a series of commandments set in stone, as an overall concept, it is riddled with unsolved problems and what appear to be a lot of self-contradictions. Some existing theories, no existing theory can explain everything, right? We can explain some observed phenomena, and we're like, okay, under this theory, this works. This makes sense. And then someone else from like across the hall in the lab goes, oh, hang on. Matt, you gotta come see these quarks, bro.
What? That doesn't fit with my models.
We need new models, as they say in Vogue. In short, it's weird. We know a thing does happen and we can prove it, but we're not sure how it happens or why. And perhaps most importantly, we don't know how to square it with other related areas of inquiry. That's why, the golden goose, the holy grail, is the idea of a theory of everything.
Oh, yeah. Well, and we still have that pesky little problem of we're unsure if observing something changes what happens. We still don't know if that's certain or not. Does it matter that we're observing it? Wait, since we're observing it, is it different than it would have been if we weren't here?
Like the double slit experiment. Yeah, that's a famous example.
It's still a thing.
Oh, very much so. Yeah, no one's answered that one. It's the theory of everything is this ancient game, right? Dating back to Aristotle. If we could just have one set of rules, hopefully a brief set of rules that explain how all of these seemingly contradicting things work together, work in concert to form what we observe as reality, then boom, we've won physics. Spoiler, civilization has not won physics yet. I was remembering in our research for this, I noticed an interesting pattern. Every few decades or so across the span of human history, someone comes forth like a prophet of old with their explanation, their theory of everything. There was a surfer who proposed an idea a few years ago. There have been various artists, various scientists who have done the same, but none of these ideas have been fully accepted by the scientific community at large because it is incredibly common for someone to propose something like a reconciliation of existing theories or a grand theory of everything, a grand unified theory, and then have some other guy come out, from like across the hallway in the lab or in the academy or something, and say, "Yeah, but it doesn't explain this part, though."
Yeah. Well, imagine what would happen if somebody truly came forth with a new theory of everything that was the real one, the actual one, and got everything right. It would disprove so many other things that we take for granted right now as being true that it would be really difficult for us to accept. And we might just throw it out immediately. And we'd say, no, that's hogwash. But it was the right one. Like the tiny little vibrating strings. I'm still betting on
String
those.
theory. Yeah. That's a pretty interesting one too. Yeah, I think that's a great observation, man, because now we see that it may be inconvenient to accept a theory, or a unified theory might require such a vast, comprehensive overhaul of existing accepted thought that it would feel like all the other work was for naught, which is something you have to be ready for in science. Science is, I can't remember if I sent this to you. There was this great stand-up clip where this guy was saying, "I hate when people say they don't believe in science. You know what that makes you? A scientist." Scientists are constantly skeptical and dissing on accepted science, right?
Well, that's the whole point.
That's the whole point.
Prove it to me. Oh, yeah? Tiny little vibrating strings? Show me.
Yeah. Is this a rounding error, or is this the most important discovery in human history? I mean, as a result, we can say new discoveries aren't really breaking the laws of physics, and law in physics means something way different than law in regular human terms. Instead, what we find is these discoveries, which I think we'll go into in a moment, they could be more correctly said to break our own incorrect earlier assumptions about the quote unquote laws of reality. Because physics, it's fallible. The rules aren't absolute. Okay, I was thinking of it this way. Okay, we're driving, right? We're all four of us are in the car together. You listening along at home, thanks for going on a road trip with us. We see a stop sign. A stop sign is an absolute. You are driving it, you approach it, you stop. That's the law. But I would argue in this analogy, we can learn about physics, because the laws of physics are much more like a bunch of extremely intelligent people saying, okay, like if the physicists are in the car, they're saying, we believe there is a stop sign here. Everything we know predicts it was probably there yesterday. We can observe that it's here now. So logically, it should be here tomorrow. But then sometimes, depending on what you discover down the road, that stop sign could change to a yield sign. It could be a totally different sign. That stop sign, that law, could disappear entirely. Like Newton's law of gravity still can't fully explain how the orbit of Mercury works. And we've been looking at Mercury forever.
That's weird. Stop doing that, Mercury.
Yeah, get it together, Mercury. Come on. Why are you so mercurial?
Yeah.
Worth it, keeping it. So laws have been broken, laws of physics. So Paul M. Sutter explains this beautifully in Discover magazine. He says, he points to one of the most famous broken laws of physics, a thing called Bode's Law. Bode's Law was proposed back in 1715 CE, and it stated what seemed to be quite rational at the time. It said, based on what we know, each planet should be roughly twice as far away from the sun as the next planet inwards. And this law seemed it was hot stuff because it works for Ceres. CERES. And then the law predicted there should be something in the region of the asteroid belt, but the law broke down after the discovery of Neptune. So people had to throw this once sacrosanct law out with the bathwater. As of this recording, we don't know which laws of physics may stand the test of time. We don't know which ones will be broken next. We can give you some of the established laws that you've probably heard in school: laws of motion, relativity, universal gravitation, thermodynamics, stuff like that. But we think it's more important to talk about how humanity, almost like the myth of Icarus, sails ever closer to things that were once thought unattainable. One of the most recent examples that we've had our eyes on is, of course, the concept of nuclear fusion.
Yes. Okay, so Ben and I are pretty close in age. When we were coming up, I want to get your opinion on this, Ben. When you were coming up, in both what I was being taught in school and what I was looking at in popular media was the concept of nuclear fission, breaking apart an atom, or breaking apart atoms to create a chain reaction, was very much a thing. That's how nuclear weapons work. That's how nuclear power works. Understandable. This concept of fusing atoms together and creating a chain reaction of fusing atoms was a theoretical thing that we might be able to do one day in the future. But right now it's just, I don't know. It seems impossible at this point.
Because we knew it was possible for it to occur as a natural process,
yes,
but we did not know whether humans could jerry-rig up the technology to do it on our own.
Yeah, how could we create an environment where that type of plasma would be formed and then be steady and, to be able to function and continue that reaction, right? At least in a chain reaction that lasts until you turn it off, basically. Well, gosh, it was early this year when I think we talked about it on Strange News, or at least maybe you mentioned it at least, mm-hmm. Ben.
Yeah.
The artificial sun that China's been working on and how it broke 1,000 seconds of steady looping plasma.
Mm-hmm.
Which, incredible. Like, if humans can actually harness that type of power, that changes everything.
Yeah, and this is a fantastic example. We did mention this on Strange News, I believe, briefly, but this is a fantastic example of how things that can look academic and maybe to fiscal conservatives look like a waste of time. This is a perfect example of how this does apply, right? Physics, the theories, the models, the principles of physics, as imperfect as some may be, do give us entry into amazing technology. In fusion, of course, fusion can be scary to a lot of people, right? For a lot of reasons. But it's important to do the cost-benefit analysis. If fusion is possible, especially under a certain price point with the right constraints, then this could mean clean energy for the world. And the implications there, just like the implications of an apple falling on Newton's head, right? The implications there go far beyond the initial foray into the field. So, I think it's also worth us noting that despite rising geopolitical tensions, which almost always hurt scientific endeavors as much as they power them, a lot of the scientists who exist in China or India or the US or Brazil or Russia, wherever, right? They are always trying to hang out with each other. I mean, yeah, they're humans, so they might have egos and stuff, but if you were a person who had spent your life researching and experimenting with something that only like 20 other people could understand, you'd want to hang out with those 20 people. You know what I mean? It's like be very into a specific genre of music. You want to hang out on that subreddit.
Oh, sure. Or somebody who's into MTG. It's very similar. Anyway, you just want to hang out with people that understand what you understand, so you don't have to go explaining everything to everybody at all times, right? Or you don't want to feel like a weirdo that wants to talk about something real specific. Like how much mana it costs. Anyway,
And why some cards are tournament legal and some are not.
yes, absolutely. And we also have to remember that all of these, the people who want to hang out and talk with each other are also working for, I was going to say companies in the form of states.
It's the MIL, the military industrial legislative complex.
Yeah, kind of. But if you look at what's happening out in Massachusetts right now, just if we're going to take this concept of nuclear fusion as a possible game changer for how countries can operate, how the world could operate. There's a fusion reactor that's being built in Massachusetts right now. There's one out in Chesterfield County, Virginia that's being built. This concept, or maybe betting on the future of what physics could achieve, happens within the state, the functional countries where they are betting on this stuff that it's going to work out and spending tons and tons of money on it, because if you do win, then your country is ahead of everybody else. Right. It's a real shame that it isn't more of what you're describing, Ben, with all the intelligent people getting together and figuring out how to do this new stuff, and then everybody gets to do it so that all ships can rise.
Yeah, but they don't like that. We have to remember the shadow of Kissinger and real politics still looms large, and quite a few world powers who control scientific endeavors, they see humanity as not a collaborative game of long-form improv. They see it as a zero-sum rush for resources, with benefit being defined as detriment to another culture, civilization, society, or player. So this stymies the research. And it's really interesting, too. This is not unique to the current era and the current discourse and tensions. It shows us that throughout history, political machination has stymied scientific endeavors. It would be fascinating to travel to a universe, maybe one spin to the left or whatever, and see what 2025 would be like if people had just worked together more often. You know what I mean? Like the fact that the space race happened is amazing, because it kind of happened out of spite. I don't know if world governments would have paid if they saw it just as pure science. I think they felt like Cold War style, they needed an enemy, which is ridiculous.
Yeah, and they also wanted to have a cool new place to shoot missiles from.
Sure, yeah, and a cool vantage point, a new perspective for other missiles, and what's going on in the stands. Anyway, this gets us to larger conversations. We said this was going to be pretty loose. Maybe we take a pause for a word from our sponsors, and we dive into some more things that allegedly break, if not laws, some assumptions about physics. All right, we're back. Okay, you might be saying, I get it. Physics is best understood as a continuing conversation. Okay, fine. Very few principles are really set in stone, but come on, guys, we know some basics, right? Like, give me states of matter. At least tell me states of matter is, we figured that one out. You got your gases, you got your liquids, you got your solids, you got a little plasma, right?
And you've got earth, air, water, and fire. Well, ice, maybe.
Mm-hmm. As David Neild explains, writing for Science Alert, quote, states of matter describe how particles can interact with one another, giving rise to structures and various ways of behaving. So if you lock atoms in place, boom, you got a solid. You allow those bad boys to flow. He doesn't say bad boys. I'm saying bad boys. You allow them to flow. You have a liquid or a gas. You force charged partnerships apart, and you have a plasma. So boom, done, right? We at least figured out matter, except we haven't.
Yeah, we kind of did, except we figured out through those particle accelerators and smashing atoms together that certain subatomic particles spin. They spin in different ways. They spin in cycles, sometimes up, sometimes down. And those little bitty things that spin in different directions do different things. And when you can get them spinning in certain ways, you can create literally new forms of matter.
Yeah, back in 2023, scientists working in the US and China discovered a new state of matter, the chiral Bose liquid state, CHIRAL Bose liquid. Nothing to do with the Bose speakers, sadly. You're not going to find this form of matter sold in your grocery store. Instead, okay, we can't get too deep here because we're not professors, but instead, this matter exists in a thing that is so confusing, it's literally called a, quote, frustrated quantum system.
Yes.
Which sounds like, an album name for a post-rock band.
Yeah, look, and here's the guy with a video degree saying this is confusing. Ben, I'm not even going to try.
Okay, here, we'll try together. And then, Dylan, if we get it wrong, we're going to forward the emails to our complaint department, Jonathan Strickland at iHeartRadio.com.
Okay. Let me give you something that is a quote. Here's a quote from Tigran Sedrikyan from the University of Massachusetts Amherst. This is how the constraints are controlled for the particles, and they get frustrated. Here's the quote. It's like a game of musical chairs designed to frustrate the electrons. Instead of each electron having one chair to go to, they must now scramble and have many possibilities in where they sit.
Mm-hmm. Yeah. So,
okay.
Yeah. I love an analogy. That's one of the best ways to learn, right? This system that they created, this frustrated quantum system, 1010 on the name, guys, no notes. It, like you said, Matt, it prevents particles from doing the normal, predictable interactions that they would have in any other system, right? The musical chairs analogy is pretty cool. It's important to note this is not just a theory that sounds good on paper. These folks actually got together and the Boffins built a system, a real-life physical system. It's a semi-conducting device, and it's got two layers. The top layer has an embarrassment of electrons, and the bottom layer has a bunch of holes for the electrons to naturally traverse into. Thing is, as Sedrakyan's saying, there are not enough holes for all the little electro buddies. So essentially, by trolling these poor electrons and leaving some homeless, these physicists redefined some of our most basic assumptions about the nature of matter. I think the Greeks would be impressed, or, maybe terrified, maybe both. Maybe they would say, hey, guys, stop.
Like, why are you doing this?
Guys, we told you it's earth, it's air, it's water, and it's fire. Please stop being dicks.
We forgot heart.
And of course, heart, which comes with a monkey. So we were also talking about this briefly off air. That's one example, but it turns out there are multiple examples of what technically qualifies new states of matter.
This is the one. Okay, we got to talk about it for a second. Yeah. Fire and ice, half ice, half fire.
Right?
It's
How?
A new
Why?
Thing. It's a new thing. That's what I was talking about with the spin. It's quantumly linked particles that have weird spin that are both fire and ice, but not really. They have upspin and downspin cycles, and when they do that, they get weird and they do weird stuff that I don't understand.
Yeah, yeah. I think it goes back to a quote we'll get to in a moment, which means so much to all of us, and hopefully to you listening along at home. Yeah, the half ice, half fire phase of matter, they call it. You can read more about it in phys.org. phys.org, a great article by Lauren McDrichian West over at the Brookhaven National Laboratory. Half ice, half fire. Physicists discover new phase of matter in a magnetic material. Look, we read through this, and we also read through a description of the work by the researchers responsible for this discovery. And gotta be honest, deep water, right? Counterintuitive, if we're being diplomatic. And the idea here is that if they find a new state of matter with what are described as exotic physical properties, and if they can take that learning and control the movement between those two states, the ice and the fire, as it were, then it could lead to some huge advances in quantum computing. Like it could have real world applications. This is not just a bunch of people growing rock crystals or sea monkeys. You know what I
No.
mean? This could change the world.
Yeah, it is for quantum because again, it's the quantum computing is the concept of having a thing that is both on and off essentially simultaneously, right? So, in human beings are using it for computing purposes right now. Who knows what else we could be using it for that we're just not thinking about yet? Which is one of the coolest things about this. That Live Science article was written just on April 1st of this year, which means we're just on the cusp of understanding what the heck, what does that mean and how do we use it? Even the amazingly brilliant people who discovered it are saying, hey, despite, this is a quote, despite our extensive research, we still don't know how this state could be utilized. We are missing pieces of the puzzle.
Mm-hmm. Exactly. Yeah.
Sorry, it blows your mind. It blows my mind a little bit.
Agreed. I think if that doesn't blow your mind, you're either one of the most intelligent physicists on the planet, or you're not really thinking about it.
Oh, okay. Well, let's think about it. Let's go to the quantum level. Some of the crazy stuff we talked about on Strange News recently. Didn't we talk about how energy was quantumly teleported pretty recently?
I can't remember if we talked about it on air, but yeah, they were able to transport it outside of the usual constraints, which would be very, very low temperatures.
But they're saying, okay, because I don't fully understand it, guys.
They're saying they could move energy on a quantum level without the same assumptive constraints that have always existed in classical physics.
Yeah, they wormholed energy from one place to another without that energy traveling through the space in between the 2 points.
They essentially teleported it.
That's exactly, and this is 2023.
Mm-hmm. Yeah.
What?
I mean, superpositioning alone is, you know what? Let's do it. First, there are even more new states of matter that are well on the way. We want to thank everybody who's doing the research for that. May regret saying this, but if you're a physicist, let us know the most exciting unsolved problems in physics. Let us know the experiments that weird you out the most. Let's go to quantum jazz while we're waiting on those emails. One of our favorite quotes about quantum mechanics comes from a legendary professor, Professor Ramamurti Shankar. And if it's okay, Matt, I'd love to play just a brief clip of his banger line.
Oh, I know this one.
You remember this one.
And one of the big figures in physics used to say, no one understands quantum mechanics. So in some sense, the pressure is off for you guys because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now, I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else.
Boom. Just like us. Not really, because we don't understand it yet.
What a cool guy, though. You know what I mean? I've watched other lectures by this professor, and just an amazing mind, and that I think that stands out to us because it's super humble, but it's also one of like the best descriptions of how learning quantum mechanics works. You learn enough to realize that you don't get it. And that's from multiple professors echo that statement.
Yep.
And so why are people so befuddled? It's because quantum mechanics, which is the fancy way of saying science dealing with the behavior of matter and light on those atomic and subatomic scales, quantum mechanics has a different set of rules of the road, and we haven't fully figured those out yet. It seems to agree with some established principles, models, and theories, and then it kind of plays jazz with the rest of it. You know, it treats the stop sign in our earlier analogy like a suggestion, or it both stops and doesn't stop at the same time, or, you know, it does every imaginable action until you look at it.
Yes. Yes. And there are actual quantum computers right now that are functional and being worked on and being used to simulate. Like we were talking about energy transportation, right? Or energy teleportation. There are quantum computers that use these concepts right now to simulate what using those concepts would be like to harvest energy from far-flung places and then store them inside themselves or inside other little qubits in the same way. Mm-hmm. And all of it just seems impossible because for me, a kid that grew up on the basic physics that were understood in, you know, the mid 1990s, all of this stuff was so outside of the realm of possibility that it really does. Man, I don't even know what I'm saying here. Just other than it doesn't seem possible that there is a thing that exists as on and off in the way we understand transistors that is so tiny, and you can link those things up in some way and then use those things to figure out stuff that our best supercomputers can't do today. Mm-hmm. It doesn't compute. Mm-hmm.
There it is. Yeah, it's enough to make some people, understandably, want to retreat back into Plato's cavern. You know what I mean? Like, yes, okay, I get that it's possible, but I feel like it should not be possible. That's where you know you get the old trope of the king shutting down the research or people punishing Galileo. Sometimes current society will take issue with truths that science is figuring out, or perhaps more dangerously, in this case, questions that science is asking. You know, civilization is a little bit better about it now, but the track record is not great. There's a dirty jacket at play. Let's go to Cody Muir, writing for Quanta Magazine, who shares some popular characters from a lot of thought experiments. There are two infamous characters who are used pretty often, Alice and Bob. So let's say Alice and Bob having a nice night at home, cooking dinner. All of a sudden, a series of events occur. Alice drops a plate. Crash. The sound startles Bob. Bob is cooking. He burns himself on the stove, and reasonably, he goes, ah! In another version of events, Bob burns himself first and then cries out, ah! And this causes Alice to drop the plate. Crash. In classical physics, only, to your point, Matt, only one chain of events is true. A to Z, 1 to 2 to 3, right? In linear time. In quantum mechanics, both of these things can be true at once due to the phenomenon known as superposition. Superposition is so cool, man.
Well, yeah, it's just Alice and Bob forever linked together, burning themselves and dropping plates. It's like,
yeah.
So cool. What do you think? What do you think the quantum quarks think about that, or whatever they're called?
They think everything at once. depending on how they're spinning. You know what I mean?
Oh, God.
Sorry, man. This is familiar, right? To any fan of fiction or film, you might hear this loosely translated or popularized as the multiverse. And like you were saying, Matt, all the particles exist in all possible realities at once up until the moment they are measured. Maybe. We think. We're not sure. And I feel like at this point in these conversations, just again for transparency, look, Tennessee and Matt and I are not currently high. It makes you feel like you're high when you have to think about this stuff.
Because you can hear this, my voice exists. And because my voice exists, my mom had to exist. And because she existed, the trees in the forest where my grandfather grew up, it's just like all of that, all of those things. When you think about the reality of it and the true thrust of physics, trying to understand why is,
right,
what is, and why.
Right. And again, the damning dilemma, the bag of badgers that we call the observable universe, which factors in human observation of time, right, is the concept of linear time and illusion filtered through senses that are inadequate for the totality of reality. Is time simply one non-linear eternal moment of the universe in some way experiencing itself through different aspects? Is there, as we're recording right now, is there still a moment in time wherein Matt pursues a different degree at Georgia State or at an entirely different institution? Is there a world in which something like me does something very similar? Impossible questions to answer because we only know the reality we can observe. And at the risk of sounding cliche, that poses a logical issue when we say observation may change things.
Well, yeah, yes. I want to say it was last year around this time when I can't remember if it was Scientific American or New Scientist. One of those publications wrote something about how human brains alter time. And it's not actually altering time, it's altering our perception of time.
Yeah.
And when it goes back to the observer concept of whether or not just us observing anything, us observing the quantum level, for the first time in human history, does that somehow alter how it functions? Or is it does it all just function that way and we're trying to harness something that maybe is outside of our possible grasp just because of scale?
Right. See also our conversation about the possibility of prescience or prognostication in dreams, right? And the quantum scale function of the human brain, right? It gets into some very enjoyable but very treacherous waters. And with that idea of, if we could correctly conflate observation and consideration, a consciousness thinking about a thing, then that counts as observation, right? And then that could mean that we run into certain cognitive dangers, info hazards, right? It's crazy, man. But I think all of this shows us just how ephemeral some purportedly ironclad laws of physics can be and how they can truly fall short of explaining the mechanics of what we know as reality. And Matt, we have not even explored black holes. We talked a little bit about quarks, but we haven't gotten down into, the great pickle of what comprises a quark. Right now, that's like the smallest thing. No matter how much energy we throw at it, we can't break it into subquarks just yet. We haven't talked about we've alluded to, but have not examined technological breakthroughs that are both powered by discoveries in physics and at the same time powering new breakthroughs in the future. I mean, maybe it's a story for another evening. Is this a part two? Do we have a part two on this, you think?
There has to be. There's going to be a part infinity of these episodes if we keep making them because stuff's getting weirder and weirder. There was a thing that came out recently about a 56-qubit quantum computer that officially, for the first time, demonstrated certified randomness.
Yes.
We talked about random number generators for a long time on the show, and what does that mean, and how do you get that?
Right.
And the new quantum stuff that we're talking about just officially did it. Pretty awesome.
Mm-hmm. And there's a new pope. You know what I mean? It's anybody's game. It's like
maybe he can come in and really solidify some of the stuff, like how things work.
And Dylan asks, what if infinite parts of this series already exist? Love it. Love the optimism there. Well, at the very least, there is a universe, this universe, wherein we continue this show, most importantly with you, fellow conspiracy realists. I don't know, Matt, in some way, to wax a little too poetic, perhaps, the first science isn't just this exploration of reality. It's kind of a metaphor, right, for humanity's unquenchable curiosity. I sound like I'm in a weed shop or a dispensary in California.
Yeah, man. Science be cool. Science is badass. It's just some of the things that are happening, I can only see them being weaponized. Some of like when you're talking about quantum advancements, it'd be a beautiful world if we could actually use that stuff to make everybody's life better, to make, to clean up the earth, to make everything cool and hippie like that. I'd be down with that, but it's not. It's going to be weaponized. It's all going to be weaponized until we can somehow drive all the weapons, into dust.
Weaponized, commodified, leveraged. I agree, especially with the constant hunt for funding, right? That is the best explanation or the best historical pitch for funding is ultimately going to be some kind of geopolitical edge or military application, which is a shame, that war should be such a great driver of innovation. But since the first moment, early humans looked at the stars, millennia and millennia ago, civilization is still, I would say, even without the military applications, civilization is searching for a pattern, right? We're taking our thumb and forefinger and rubbing the weft and weave of reality's fabric, and we're always seeking a hole in that substance, right? And maybe we can get behind the curtain. Maybe we can discover a vast conspiracy, right? The truth that scientists and religious institutions have sought ever since we thought to seek things. So I don't know, man. It looks like we just arrive at more questions than answers. Is that a fair statement?
I think so. I'm just going to sit over here and rub the waft and weave.
Well, while we do that, we want to hear from you. What will we learn next? Should humanity, should civilization keep asking these questions? Or is there a moment where everybody collectively says, that's enough, we don't need to learn more? We can't wait to hear your thoughts. You can find us online, YouTube, Instagram, any social media that you may sip. We are Conspiracy Stuff Show, some derivative thereof. You can also find us via telephone and email.
Yeah, our number is 1-833-STDWYTK. When you call in, you've got 3 minutes for a voicemail. Give yourself a cool nickname. Let us know if we can use your name and message on the air in the message. Please do say that. And hey, if you want to contact us another way, why not send us a good old-fashioned email? We are
the entities that read every piece of correspondence we receive. Be well aware yet unafraid. In multiple universes, the void writes back. What do we mean? You can find out by playing along at home. Conspiracy at iHeartRadio.com.
Stuff They Don't Want You to Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.